Hello, welcome to our session today for engineering economics. We're going to talk about the time value of money. So in order to understand this, probably the easiest way is to um, ask the question, would you rather receive $1,000 today or a year from now? Most people would answer that they prefer the money today. And one of the reasons for doing that is because there is an opportunity cost. What do we mean by this opportunity cost? Well, the opportunity cost is what we could have done with the money if we had it before. We could have invested it and therefore providing us with some other income, or we could have used it for some kind of satisfactor, maybe food, maybe shelter, maybe some recreation equipment. And the reason that the fact that we are not having the opportunity to enjoy that now represents a cost for us. So that's one reason why we want to have the money today, the opportunity cost. A second reason why we want the money earlier rather than later is the risk. Why would we want to risk not receiving the money if we have to wait later compared to the option of having it now? Anything could happen. There are risks associated with time and the fact that we have to wait either in financial markets or in business, and it might be that we will not receive the amount of money. So there is a risk associated with the fact of waiting, and that risk is a cost as well for us. So there you go. You have two good reasons why you rather have the money earlier rather than later. And that is why money that is received earlier has a higher value than money that is received later, even if it's the same amount. So the time value of money is associated with an opportunity cost and risk. However, it is not the same as inflation. Inflation is the fact that money loses purchasing power through time, and because of that we might have to pay higher prices, and we might think that that's the time value of money. It is not. Even if in an ideal world in which there is no inflation and the same product will be bought at the same cost regardless of if we buy it now or we buy it, say, 1 year from now or maybe 2 years from now, still we would be interested in receiving the money earlier, even without inflation, because we still have the opportunity cost and we still have the risk. One way that time value of money is manifested in society or in our everyday transaction is the interest we pay when we buy something at credit. Also, we have interest rates. The interest rates are also called discount rates, and that's another term that I'm going to be using. And the time value of money is also, or can also be called, the cost of capital or the minimum attractive rate of return. These two last terms, cost of capital and minimum attractive rate of return, will be explained in more detail later. Since we are going to be dealing in this course with when we're going to be receiving the money, it's important to understand what a cash flow is. A cash flow, it represents money that will come out or into the pockets of the investor, or it's available for the investor as a consequence of the development of a project. That is, for instance, an initial investment would typically have a negative sign, and it's a negative cash flow since it's money that is no longer available as cash for the investor. Many years later, maybe because of revenue increase or savings due to this project, the investor might receive cash back that will be available for him, and that would represent a positive cash flow. Cash flows can be represented in through time with the help of a cash flow diagram, and here we have cash flow diagrams with a couple of single amounts. In this example, we have a cash flow that happens at t equals 0 and a cash flow that happens at t equals 9. The cash flow at t equals 0, it's denoted with letter P. Typically, P will be used to represent a present value and F a future value. The cash flow that we have here t equals 0 is the arrow is pointing down, and that means that the sign of the cash flow is negative, and that represents money that is no longer available for the investor. And in this diagram we have 9 periods between the two cash flows, and the last period at t equals 9 we receive, or the investor will receive or will have available the cash flow back. In this diagram, purposefully the arrow pointing up with the last t equals 9 is larger than the arrow pointing down, and what that tries to represent is the fact that that cash flow is a little larger than, or it's somewhat larger than P. Also, P stands for present and F stands for the future, but the present is just a relative measure with respect to a possible future. That is, it doesn't have to be in all the cases the moment right now, but we will explain that more in detail later on. It's important to note in this diagram that the time we're calling t, say t equals 1, it's at the end of the first period. So in general, unless otherwise stated, when we talk about t equals 1, it is an instant in time, not the period, and it's the end of the first period. And in the same fashion, if we pay attention to t equals 9, then t equals 9 actually is the end of the 9th period. Several cash flows can be represented in the same diagram, and in those cases we would have a cash flow series. This cash flow series could happen in a periodic way or not. That is, it could happen every so often, or they could have non-predictable periods in time, and we will use these diagrams to represent the series of cash flows, and that will facilitate our understanding on when the cash flows are happening and how we can use different models that will help us solve for these problems. So in summary, the time value money represents the fact that even when two same amounts of cash flow could be received in different moments in time, the actual value that they will have will be different. Also, in this video we saw what's a cash flow diagram and how we will use it to represent when the cash flow occurs. Thank you very much.